We're going to look at an example here to put into play all those formulas associated with the sampling distribution of the sample mean. So we will find probability associated in part A with an individual, and then in the subsequent parts we're going to talk about probabilities associated with a sample, and this is part B, says sample size 20. In this example, we are given a variable, the length of human pregnancies, and we're told that it's approximately normally distributed with a particular mean of 266 days and a standard deviation of 16 days. So part A here, we are going to find a probability associated with a single pregnancy, a randomly selected pregnancy, and what is the chance that it lasts less than 260 days. And we're also requested to provide a sketch. Now for the sketch is just to kind of visualize what we are doing. So this question does not require any knowledge of the sampling distributions from the previous video. This is kind of like a review example, but we're going to extend upon it. So we want to find a probability with this normally distributed variable. So let's first do the sketch. I think that will help guide us a little bit. So this is our variable, we'll call it x for length. We're given the mean, 266, and we want to find the probability that a individual pregnancy lasts 260 days or less. So if I was to highlight a portion of this curve, should I highlight to the left or to the right of 260? So, because it says less than, I'm going to highlight the region to its left. So remember how we approached these types of questions. We're going to convert 260 days into a z-score. So the basic z-score formula here is x, particular value of pregnancy length. How far away is it from the mean pregnancy length, divided by standard deviation. So we are given all this info, so let's put it to use. Z, our particular pregnancy length, x, was 260. We're going to subtract 266, divide by the standard deviation of 16. So I'm going to pop open my calculator here for us. Okay, so we've got 260 minus 266. That's going to give us a negative number because we can see that's below the mean. 260 is below the mean. And divide by 16. So this provides us with a z-score of negative 0.375. Because the z table that we're using really only has 2 decimals worth of precision to the hundredths place, I'm going to round that to 0.38. So that's approximately. But remember, that's not the answer. We can't have negative probability. What we need to do is take that value to the z table. So we're going to go to the z table to find this probability. So we're going to look up negative 0.38 on our z table, which I've got loaded up here. So negative, there's that negative side, 0.3, and I need to go to the column that says 8. Now you may not see it there, but I know that the very last column has the second decimal place of 9, so I know I need to look at the value in the second to last column. So 0.3520. That will be our probability. 0.3520. Part A was about a single or an individual pregnancy length. Part B is now asking us to consider a sample of 20 pregnancies. 20 pregnancies. So that is our sample size. N equals 20. So actually, we're not going to find a probability yet. We're just going to describe this sampling distribution and provide a sketch as well. So let's discuss the shape, the center, and the spread of this sampling distribution. So the shape here, we were told in the beginning of the problem that the original population was normally distributed. So that is going to apply directly to this sampling distribution. So over at shape here, I'm going to state that the sampling distribution is normal because that was given in the problem. Now the center of this normal distribution, we'll draw a picture in a moment. This is the mean of the sampling distribution. It should just be equal to the population mean. But again, that was given information up here. So I'm just going to take that info and just say 266 days. Great. Now for the spread of the sampling distribution, I'm going to utilize that formula that we have from above, where we need to look at the standard deviation that was given, that's the 16 down here. We're going to divide it by the square root of our sample size. So sigma over square root of n So that's going to be 16 over square root of 20. So I'm going to get my calculator back out, and we'll do 16 divided by the square root of 20. About 3.5777. About 3.5777. So to draw a figure here to sketch this sampling distribution, I'm going to draw these properties. We were given the info that we have a normal curve, the center as at 266. And if I was to label this, I'm not just going to label it X, but I'll label it X with a bar. Okay, so now that we've got this distribution, we know what it looks like. Let's find a probability associated with it in part C. What is the probability that a random sample of 20 pregnancies has a mean gestation period of 260 days or less? So, to mimic the procedure from part A, we're going to use the z-score formula. That's been slightly adjusted to fit or to apply to sample means. So we want to plug in the sample mean that was given for X bar. That is the mean gestation rate that was given of 260 days. So that's what we will plug in, 260. And subtract the mean, 266, that's what we see above. And in the denominator, we need the standard deviation of the sampling distribution That's the spread given right here. So we've already done some of the math, so I'm just going to write in the denominator 3.5777. So let's do 260 minus 266 divided by 3.5777. This is our z-score. I'm going to round that to 2 decimal places, so negative 1.68. Just like earlier, that is not the solution. That is our z-score that we want to take to the z-table. Z-table to find our corresponding probability. So, negative 1.68 at the z-table. I got negative 1.6. I'm going to go over to the column that I know says 8. Highlight that value there for your reference. So the probability that a sample mean gestation period being less than 260 days is 0.0465. 0.0465. So if we were to put this onto this figure up here, that 260 is actually pretty far over to the left, right? And we're finding this area over here. So that 260 seems so much further to the left because the spread of the sampling distribution is a 3.5 approximately. So that is in a very small number, much smaller number compared to what it was earlier, which was 16. That was for the population. So the general process to find a probability here is the same as we did earlier in our class. We've just now integrated this sample size, the square root of n, into the spread here. Let's look at part D. In part D, we're asked to find the probability that the random sample of 20 pregnancies has a mean gestation of 260 days or more. So this sounds very similar to what we had just completed. However, this is a greater than question, right? 260 days or more. However, all the other components have not changed. So this is a very simple question since we've already done part C, because we just need to take the complement to our solution from part C. So our answer, 1 minus 0.0465, so 0.9535 is the probability here. So remember, when we do greater than or probabilities that refer to more than, we usually end up doing a sort of complement. Now let's look at part E. This is our final part. Notice the question here, we still have a sample of 20 pregnancies. That is still our sample size. But notice that this question is asking us to find a probability in between two values. In between two values. So I'm going to draw a quick picture here to illustrate this. It's going to look very similar to some of our previous images, but a nice clean canvas will be nice. So this is the sampling distribution of sample means. And so I'm going to draw a normal curve over here, label it X with a bar. We know the center is still 266, and we want to find the probability between 260 and 270 days. So this is a region in the middle here, right? An in-betweener. So I'm going to shade this in-between zone. That is the region we want to find. So just like earlier, we want to find these probabilities using the standard normal distribution by using z-scores. Now, we already know the area to the left of 260, right? The area to the left of 260, we don't need to go find a z-score for that again. We know it's 0.0465. Now, that's not the area we want, but we're going to use that in the near future. Because what we do need to do is find the probability, or the area to the left of 270 by finding a z-score, going to the z-table, and then we're going to do a subtraction. So we're going to need to do the z-score for 270, subtract the mean. Because this is still applied to the sampling distribution, I'm going to divide by that 3.5777 from earlier. We'll do 270 minus 266 divided by 3.5777 to get our z-score of about 1.12. So this is approximately 1.12. Just like earlier, we're going to take that z-score to the z-table, find the corresponding probability to the left of 270. So that's a positive z-score, 1.12. I will highlight that value. And that is the area, or the probability, below 270, 0.8686. But that is the area to the left of 270. So we want a fair portion of that region. However, the portion we do not want is the probability to the left of 260 days. So we need to subtract those two probabilities from each other. So doing this subtraction, we get 0.8221. And that is our solution for the probability that in a random sample of 20 pregnancies, that the mean gestation period is between 260 and 270 days.